Hey guys, welcome to Pre-Calc lesson 6.1, Introduction to Conic Sections, Factoring, and Circles. First, let's talk about what a conic section is. A conic section is simply a slice of a cone. So today we're going to talk about circles. I'm going to jump to that one first. If you slice a cone parallel to the base, that slice results in a circle. If you take that slice and you start angling it upwards, you get an ellipse. From there, if the slice is parallel to the edge of the cone, that intersection would be a parabola. And then if you move more vertical from there, that intersection becomes a hyperbola. Here's another illustration, the four conic sections in one cone. And again, you can see parallel to the base is a circle. Then as you move beyond that, we go ellipse. Parallel to the edge of the cone gives you a parabola. And then as you move vertical from that, you get a hyperbola. And that's the order in which we're going to learn these conic sections. Over here, we have a two-dimensional representation, which is obviously what we'll be graphing. Now, one thing we do need to know, something called general form. General form of a conic section looks like this. ax squared plus by squared plus cx plus dy plus e equals 0. Now, all conic sections have this form. What determines the type of conic section? The value of a and b. All right, so I'm going to say the type of conic section, and what I mean by that, circle, ellipse, parabola, hyperbola, is determined by the values of a and b. So do they have the same signs, different signs? Is one greater than the other? Is one 0? Those questions will answer, and it determines the type of conic section. All right, so before we get into that, let's take a look here at factor by grouping, because these are some skills that we'll need for the entire unit when we go from general form to standard form. We always use standard form for graphing because it's much easier, but we have to get there first. So just a review of some skills from earlier this year in Algebra 2. I'm going to go through these quickly. I'm hoping you guys already know them, but if you don't, no problem, just follow along. So the first one, I'm not actually going to use grouping. It's just a GCF situation. The GCF here is 3x. And remember, what goes inside the parentheses is what you get when you divide both of those by 3x. So I believe here we get 2x plus 1. And that's factored. In my second one, the GCF is actually a binomial, x plus 1. So I would factor that out, x plus 1. And what I have left after I do that goes inside the other set of parentheses. So that's going to be x squared minus 4. Now this I can factor again as the difference of two perfect squares. So to completely factor this, I'd have x plus 1 times x plus 2 times x minus 2. Pretty easy stuff. It gets a little bit more challenging here because now I truly have to factor by grouping. I'm going to group these two. I'm going to group those two. All right, so group those, group those. In the first two, I can take out an x squared. What's going to be left is 3x plus 1. Now, in order to factor by grouping, we've discussed this earlier, I kind of cheat. I know this has to be a 3x plus 1 over here in parentheses. So how do you go from here to here? Hopefully we can take out a 5, and indeed we can. So I'm going to take out a 5, and then in parentheses I have 3x plus 1. So now the GCF of these two terms is 3x plus 1. So that's what will come out. And what we're left with is x squared plus 5. This does not factor, so we're done. Can't do anything more with that. All right, example 4, a little bit tricky because they gave us a negative here. All right, but what I'm going to do is I'm just going to factor out a negative as well as an x cubed. So let's take out negative x cubed. What's left is a positive x plus 3. So again, just a reminder, I need this over here. Hopefully you can go from here to here by taking out a GCF, and obviously we can. We'll take out a 2. So plus 2, and then I have x plus 3. The GCF is x plus 3, and we're left with negative x cubed plus 2. All right, let's move on. Completing the square. Again, I know this is a little bit of review, but these are skills that we'll need throughout the unit, so I just want to review them quickly. In an equation to complete the square, first thing I'm going to do is move this to the other side, so I'll subtract 21. All right, that's going to give me x squared plus 10x, and then I have a negative 21 on this side. Now, the procedure here is you take this, divide it by 2, and then square it. I have to add it here, and I have to add it here. So half of 10 is 5. 5 squared is 25. Add it to both sides. Super important, right? This is a mistake that we see a lot as teachers, is forgetting to add it to the other side, trying to do too much in one step. This next step, I don't normally show. I'm going to do it one time today, and then after this, I'm not going to go here because we should kind of know it at this point. The reason we complete the square is because it creates two identical factors. This is always adding, so the signs are the same, and they're both going to be whatever this is. So if this happened to be negative here, then these are both negative. But taking half of this and squaring it always gives us a number that gives me two factors that add to this. That's why it just works that way every time. So I get x plus 5 squared equals 4 and blah, blah, blah. We're not going to solve these today. We're going to use this, like I said, to come up with another equation. This is more in line of what we're going to do. Factor by completing the square. So notice here, I don't have equations. Those are just expressions. But I want to factor those in some way. Right now, they don't factor. So what I'm going to do first is I'm going to separate my x terms from my constant term. Now, I'm not subtracting because it's not an equation. I'm just moving it out of the way for now. Then I will complete the square on this. So half of negative 4 is negative 2. Negative 2 squared is 4. So I have to add 4. Well, that's not that big of a deal, except when I add a number to an expression, it changes the value of that expression. So what you see here is not equivalent to this at all. So how do you balance an expression? Well, if you add 4 to one part of it, you have to subtract 4 on the end of it, because now these two balance out and give you 0. So by doing that, now this expression is equal to this, exactly. And it allows me to factor that. I get x minus 2 squared, and now you just have to combine those. 1 minus 4 is a negative 3. And there's an expression that's factored, so I could use this maybe in the equation somehow, determine a center or vertex or whatever, depends on the type of conic section, whereas I could not do that up here. Okay, let's do a similar one. Let's group the x's. Let's move this 10 over a little bit and complete the square on this. Okay, so half of 12 is 6. 6 squared is 36. I'll add 36 here, but I have to subtract 36 on the end. Because remember, these have to give me a 0. Because this whole expression has got to remain equal to that one. Okay, so I get x minus 6 squared. 10 minus 36 is negative 26, and that's as much as you can do with that. Okay, let's talk about circles now. First of all, what is the definition of a circle? If you had to define a circle for your parents or a friend, how would you define a circle? Well, you define it as the set of all points equidistant from a fixed point. And that fixed point is what we call the center. Standard form equation of a circle. This is also known as center radius. Looks like this. X minus h squared plus y minus k squared equals r squared. Hopefully we know that already. This gives us the center as hk. And notice these values here are the opposite of what you see in the parentheses or in the factors. And I know my radius equals r. Whatever this number is, that's the radius squared. The radius is just r. General form. Okay, we talked about this a little bit. It's going to be ax squared plus by squared plus cx plus dy plus e equals 0. So how do I know if this is a circle and not an ellipse or a hyperbola or a parabola? Well, for a circle, A equals B. Doesn't have to be 1. They can both be 2. They can both be 4. But those two will be equal and also the same sign. Okay, let's get to some circles. All right, examples 1 and 2, they just want us to list the information. So example 1, they gave us an equation in center radius form. What's the center? What's the radius? Pretty standard stuff. My center is going to be 3, -4, and my radius is going to be the square root of 49, which is 7. Again, normally I don't write the square root up. I'm just reminding you guys where it comes from. In example 2, they give us a center and they give us the radius, and they want us to probably write it in center radius form. So again, not that big of a deal. It's going to be x minus the x coordinate. So x minus the -5 is x plus 5 squared plus y minus 8 squared equals, now remember what goes here is r squared. So the square root of 30 squared is just 30. Okay, next we're going to go from general form to center radius form. This is something you guys did in geometry. We did it in Algebra 2. Again, I'm going to go a little bit quickly here. The most important thing I find with these is showing your work. Too many of you guys kind of rush the process. I'm going to add that to both sides. So it's going to be +5 over here. So now I need to complete this square twice. You complete it once for the x's. So I'm going to add some number here, and then don't forget to add it over there. Then I have to complete the square here. So again, I'll add some number here and then add that number over here. So you're going to be adding 2 numbers over on this side. Okay, for the x's, half of 6 is 3. 3 squared is 9. Add 9 here. Add 9 there. For the y's, half of 8 is 4. 4 squared is 16. Add that to both sides. All right, x squared minus 6x plus 9 factors to x minus 3 squared. Y squared plus 8y plus 16 factors to y plus 4 squared. And 5 plus 9 plus 16, what's that, 14, 16, 30. So great. Here's standard form. I can identify the center as 3, -4, and the radius as square root 30. All right, this would be calculator inactive, so don't worry about writing that down as a decimal. Okay, another one. I've got, here, let me separate that. X squared plus 4x, we group our x's, plus y squared. There's no y term. Okay, subtract 3. Now we only need to complete the square on the x's right here. So it's going to be half of 4 is 2, 2 squared is 4, add 4, add 4. Now I can put that into standard form. X plus 2 squared plus y squared equals 1. The center is going to be -2, 0. Because remember, that y squared we could write as y minus 0 squared. So that's where the 0 comes from. And the radius is the square root of 1, which is just 1. Okay, I'm going to do one more. If you're good with that process, you can skip ahead to the next example. I'm just going to go through one more time here for those of you that might need a little bit more repetition. Group your x's, group your y's, and subtract 4 to the other side. Complete the square on the x's. Half of 6 is 3. 3 squared is 9. Make sure you add it on both sides. Complete the square on the y's. Half of 4 is 2. 2 squared is 4. Add it to both sides. Factoring the x's, I have x plus 3 squared. Factoring the y's, I have y plus 2 squared. -4 plus 9 plus 4 is just 9. There's your center radius form or standard form. The center is -3, -2, and the radius is the square root of 9 or 3. All right, excellent. Moving on. A little bit more challenging now. I want to find the equations given certain conditions. So the first one says, find the equation of a circle with a center at 1, 4 that passes through the point 4, 8. All right, well, how do I do that? Well, I'm going to make a sketch here. The center is 1, 4. So 1, 1, 2, 3, 4. There's my center. Passes through the point 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's my center. Passes through this, so that means I'm not going to draw the whole thing, but it kind of looks like this. Now, as soon as they give you the center, we can do the whole left side of the equation using that point there. So I know it's going to be x minus 1 squared plus y minus 4 squared equals r squared, whatever that happens to be. So what I need to do is I need to find this. That's r. Well, I'm sure you guys remember your distance formula from geometry, right? Distance equals square root x1 minus x2 squared plus y1 minus y2 squared. You guys want to do that? If you had Mrs. Mandrano, you remember that formula, Sleepy Owl. I'm not a huge fan of that formula, and I taught geometry. Here's what I like to do. Make a right triangle. All right? It's where the distance formula comes from anyway. It's easy enough to count. We're going to give you small enough numbers where you can count this. The bottom side of this triangle is 3. This side of the triangle is 4. I'm hoping you guys remember your triples. There's a 3, 4, 5. If you don't, you're just going to have to use Pythagorean theorem. So my radius here is 5. What goes up there is r squared. 5 squared is 25. All right, let's try another one. Find the circle equation with the center of 3, negative 2 and tangent to the y-axis. So before I even get to the sketch on this one, if I know my center is 3, negative 2, I'm going to start the equation. X minus 3 squared plus y plus 2 squared is going to equal r squared. Now let's make a sketch. 3, negative 2. There's my center. Well, what does it mean to be tangent to the y-axis? Well, here's the y-axis. When you're tangent to something, that means you only intersect it one time. So the circle's got to look something like this. All right, so that's kind of easy to sketch. Goes through here. I think it's easy to see. I need that radius, and that's going to be 3. So that's going to be r squared. 3 squared is 9. There's your equation. All right, one more. Last one. Find the equation of a circle with endpoints of a diameter at 2, 3, and 2, 11. So no center. Can't start the equation. What I'm going to do here is let's make a sketch. One endpoint is 2, 3. The other endpoint is 2, 11. 4, 5, 6, 7, 8, 9, 10, 11. Now these points are kind of far apart. Maybe it is helpful if we write the coordinates next to each one. So those are the endpoints of the diameter. Here's your diameter. That means your circle kind of looks like this. So what we need to do is we need to find the center. Well, one way you can do it is you can take these 2 points and go back to geometry and remember your midpoint formula. Right? You guys remember that? Again, I'm not a huge formula fan, especially recalling formulas from 3 or 4 years ago. So let's be visual. I know that this diameter goes from 3 to 11. Well, 11 minus 3 equals 8. So this diameter is 8 units long. Well, what's half of 8? It's 4. Let's go up 4. 1, 2, 3, 4. There's your center. What are the coordinates? 2, 7. You can count, or you can just add 4 to 3. So now that you know your center is 2, 7, I can write the left side of the equation, x minus 2 squared plus y minus 7 squared equals, and I just need the radius. Well, we kind of already discussed what the radius is right there. Radius is 4. That's going to be r squared. 4 squared is going to be 16. That concludes day 1. It's going to be very important for you guys to stay current. This is probably review for a lot of you, but ellipses will not be. Hyperbolas will not be. What we do with parabolas will not be. So it's super important that if you guys have any questions as you move forward here, especially early on in the unit, that you reach out, you get help via office hours or math clinic or after school. Also, please be diligent about doing the homework and checking your answers. This is one of the more challenging units we do in the entire school year, so it's really important that you guys stay with it. Thanks a lot for watching, guys. I appreciate it, and don't hesitate to reach out if you have any questions. See you in class soon.